Good afternoon, and thank you so much for joining us. We're proud to present our next speaker, Nikita Ivanov with GridGain Systems. Please give him a warm welcome.
Can you guys hear me? All right, excellent. So thanks for stopping by. I know you guys getting tired by now, so for the next 20 minutes, what I'm going to talk to you about is just a quick, kind of conversation about memory computing and how it relates to something what we call a digital transformation. I know most of you probably sick and tired about this terminology by now, but it's kind of interesting conversation. We are a fairly large open source project in the company around it. And I want to give you kind of perspective, not from kind of analyst point of view, but from a kind of vendor field point of view. What are we hearing about in memory computing, how it's been used, and how it's been used in the cases where people are really transitioning to kind of new type of businesses, new opportunities. So just a few words about what we do at GridGain. We essentially develop what I call a leading open source in-memory computing platform. It's really a type of software that slides in between your applications and data sources and provides you the speed and scalability. And we'll talk about this. And it's interesting, this slide actually, if I would be presenting this, 10, 15 years ago, all these kind of industries you have, not industry, but the actual use cases are kind of, almost all over the place. But 10 or 15 years ago, it was predominantly fin services and financial services that's where we're using the memory computing. But today we're seeing quite a bit of a usage almost across any spectrum of use cases, industries, and whatnot. As I mentioned, we're based on Apache Ignite. We were original developers of Apache Ignite project. I was at the beginning of it almost 15 years ago. Today, Apache Ignite is one of the top projects in the Software Foundation, Apache Software Foundation. This is actually a ASF report. I think from early this year, we're number 1 in the mailing list, number 2 in the user list. And those are very important metrics for a software in an open source project specifically, because it gives you the vibrancy, the activity of community, the life of the project itself. And we're literally number 5 in commits, which is a pretty cool stuff for an open source project. Let me talk about the benefits. It's an interesting slide. I think most of you, if you're in technology, you sort of intuitively understand what is the benefit of a memory computing, right? Speed. You move data into the RAM and DRAM, things go fast. What I think most of you, if you're not involved in it specifically, I think a lot of people, in my experience, don't realize that in memory computing systems are one of the most advanced distributed systems as well. And by necessity, by the way. If you look 10, 15 years, 20 years ago, a single computer would have barely a megabyte of RAM, a megabyte. And back then, in the mid-90s, late 90s, you had to string together many computers together in a cluster to have any usable amount of RAM. And I remember back then, that was necessity. Nobody was doing this. I remember, mid-90s, who was doing distributed databases? Nobody. You don't have to, because you can keep the entire thing in a single, network attached storage or a disk. You don't have to. In the memory computing world, you had to. And it's just kind of a little bit of untold secret that in memory computing systems, at least most of them, one of the most advanced distributed systems. For example, at GridGain or Ignite, we have one of the largest clusters in the world. We have a number of production customers with over several thousand nodes in a transactional topology. You can only find this scale with Facebook, Hadoop installations, and things of that nature. So the scalability is also a benefit of the memory computing. But also, in many ways, is the simple way or simplicity in which you can implement this. If you remember the previous slide, and I can switch to this one right now. We literally slide in between your applications and data sources. And that's not the way that typically, for example, memory databases would work. If you're deploying a memory database, the conversation will be pretty simple. Well, if you have your Oracle, well, remove your Oracle and put our database, whatever it is. And typically, memory computing systems do not work this way. You can do that, for example, with Igniting GridGain, we support full SQL 92 if you need SQL 99, as a matter of fact. But You don't have to do it. You can slide in between. You can move as much data as you need into this layer. And this layer gives you a tremendous performance benefits. We're typically talking about an order of magnitude. Now think about it for a second. Where else can you get an order of magnitude performance today? It's not a simple thing. You cannot buy a CPU or a faster flash or anything else. To get something 10 or 100 times faster, it's a fairly remarkable achievement. And in memory computing, regardless of which company, just as technology and approach, is about the only way you can do it today. So, in terms of what do we do essentially, as you can see in the slide, we built on Java, but we have plenty of ways to work with us. We support SQL, we support full .NET clients, PHP clients, and Node.js, and the rest of it as well. Some of the use cases for us. I hate this build-up. Anyways, it's one of those slides that's changing literally by every couple of years from us. Again, if you would see this slide from me, 10 years ago, if you see this slide 10 years ago, I probably would just have a core banking, maybe trading platform. That's where it's all started, because speed is money. Speed is money for those guys. But today, we literally have customers and clients, across the board, anywhere from iPhone games and PlayStation 2 games, and PlayStation 3 and 4, anywhere to investment bank, book management, book of business, plenty, credit applications, credit scoring, fraud detection, manufacturing, almost in any imaginable ways. So let me kind of switch it back a little bit into the kind of digital transformation, because that's what we kind of see in our kind of medium-sized to large clients. I hate to quote Gartner often, but this is actually a pretty good definition of what is digital transformation. It's a very loaded term. It kind of talks about everything and nothing at the same time, but I kind of like this way. So digital business transformation, let me just read this one, is a type of journey a company can undertake to literally pursue a new net revenue stream, net new business or services, and net new business models. And the best way to look at this is basically look at this. And I think this is actually very nicely kind of highlights it. So if you look at what we've been doing for the last 50 years, we were adapting technology for the needs of our businesses. We were constantly basically using IT technology to do the proverbial increase the productivity and reduce the cost. That's what we've been doing. If you think about it, anything we do with the computers and the internet and the cloud, up until literally a few years ago, increase productivity, reduce the cost, make things go faster, produce faster, cheaper, and whatnot. What I think digital leaders do today, and we can actually see this literally on a probably weekly basis as we talk to customers and users, they're trying to adapt businesses to a new capabilities and technology. It's a very remarkable change. Again, it sounds very vague, but think about it for a second. All of us grew up thinking about technologies, the ways to reduce the cost, increase productivity, and yada, yada, yada. And today, there's plenty of examples. Today, we're thinking about how to change the business to really adapt to the technologies that are actually available. Perfect example, I don't have a slide for it, but I'll give you an example for this. McKinsey did actually a very interesting study about the connected cars. Think about this, cars. Most of the cars today, they're connected. Look at Teslas, right? And in 10 years from now, almost every new car will be connected. What is the car? Car essentially is the large moving container of sensors. We have sensors, right? Our phones, the watch, but the cars have dozens of sensory, and they are constantly sending information back and back. So McKinsey basically calculated that in about 10 years, by 2030, the revenue, if you take a company like General Motors, the revenue from monetization of this data will exceed the revenue from selling cars. Now think about it for a second. About 100 years ago, we had a startup called Ford that introduced the new, very interesting way of transportation. For the last 100 years, we've been making this product better, better, cheaper, better, better, and by now, by next 10 years, we're going to change completely the way it works from a business model perspective. the data that it's generating will be more valuable than the product itself. And that's actually a disruption, as you can imagine, as disruptive as you can imagine. And that's why you're seeing, GM and everybody else in the Ford investing billions upon billions in this direction, because that's inevitable. And that's just the one industry. You can find almost exactly the same examples in GE, in the jet engines, in other forms of transportation, in healthcare, everywhere else. The data is becoming the key, and that's an example. So how does in-memory computing really fit into this? It fits very nicely. I mean, a lot of these new type of businesses coalesce around the idea that we need to, the data is flowing, obviously you all heard about it. Yeah, there's a massive amount of data constantly flowing in. You have to process in real time, if not in real time, in the smallest time possible. And in-memory computing is the one way, basically about the only way, by the way, at this point, to have any hope for real-time processing. What's interesting about in-memory computing is that there's really nothing behind in-memory computing as an idea. It's also a very interesting topic when I speak about this. A lot of people don't realize this. If you look at it historically, we had tapes before, and around 50s, right? Then the disk came over, then the flash came over, and we always knew there is something behind this. There was always a next technology that's available. What's available behind the DRAM? There's nothing. In the current architecture of our computers, byte addressable RAM that's connected to CPU is the end of the road. The RAM itself will be cheaper, the bigger, different types. There's Optane from Intel and whatnot. It will obviously become non-volatile eventually, but it's still going to be byte addressable RAM, and we're still going to work the same way with it today as we work today through the same interfaces. So the storage and processing of data in RAM is a fundamental end of the road in the evolution of data storage. That's why, you can hear in this conference, everywhere else, in-memory computing is not a stopgap sort of technology. It's there. We and our kids will be working with the same technology, different types of memory, but the overall approach will be pretty much the same as we go. So, it's again, by the way, a slide from, I think from one of the Gartner presentations. So memory computing is evolving. We at GridGain is kind of forefront. We're about the only company today that's fully dedicated to memory computing as a technology. And we already kind of, envision the idea of a platform. But today you have plenty of kind of, dispersed product, whether it's a database or data grids, analytics, streaming, and whatnot. And we believe that it will all coalesce into the platform, because you not want to buy a patch solutions and then spend years integrating them in a solution that you need. And we strongly believe the in-memory computing platform is the way to go, because you're buying or using a single platform. It gives you data grids and SQL, transactions and streaming, machine learning, TensorFlow integration, all these things that we actually have in the platform. Just a few words about who's using us. And again, that's less about us, more about the advancement of memory computing. Literally, you can look at the slide, it's predominantly almost every walk of life, every type of industry, from financial services to software tech companies. Some of them are here. We have plenty of customers in this conference. Something boring like logistics and transportation, you would never think that they will use something like this. They do use a lot of memory computing. Fintech, IoT, EdTech, healthcare, mobile games. We have plenty of customers, as a matter of fact, doing a monetization backend engine for the mobile games and a variety of different games. So, in-memory computing is here, and again, you may not have a perspective, but we at GridGain, we kind of seen this over the decade evolved, and again, as I often say, 5 years ago, half of this, the rectangles would not be even here. And probably in 5 years from now, it will become a lot more ubiquitous with more products and more simplification available to it. Lastly, but I want to leave you with a statement from a very conservative bank in Europe, ING Bank. And I think it kind of, highlights the idea what digital transformation is all about. ING is very conservative, it's a very large bank. And the way they think about themselves is this. They want to be a tech company with a bank license. And that's pretty much the same way like this company, Amazon, thinks about themselves. They don't think about them as a retail company or a cloud computing company. It's a tech company with a retail license. Same as, if you go any other companies with the same way, if you listen to Ford and GM, again, back to car analogies, Teslas, they don't want to be car companies. They want to be tech companies that happen to produce an object, a widget like a car or anything else that produce the data as well. So this is the best way to think about it going forward. So summary, try to become a leader in this digital transformation. Try to think about this not as a cost savings, but really the way to find new products and new services. I know it sounds cliche, you're almost thinking about it anyways, but it's always fine to remind this and give you some examples. And memory computing really is one of the key technologies to, one of the pieces, not all of it obviously, but it's one of the key pieces in this journey that you will need to really implement this vision. Thank you guys.